In this video, I'm going to teach you the most effective strategy for acing technical coding interviews in 2025. If you choose to adopt this style of preparation, I'm absolutely certain you will learn complex algorithm topics more quickly, have a true understanding of these topics instead of just memorization, and as a result, land more job offers, which is why we all do this annoying coding prep. We want to be employed. First, let's go over the different ways most people prepare for coding interviews. After hopping on the LeetCode website, the most common approach is to sort by problem frequency and solve one by one the most commonly asked questions by tech companies. Another common approach is just solving random problems with no strategy. So this is really to get a bunch of reps in for solving algorithm problems. The last common approach is to focus on a single algorithm topic, such as sliding window or graphs, and then apply the other two approaches mentioned. So sort by frequency in a specific category, or just solve random problems in a specific category. These approaches suck. I promise I'm not a hater. I did a combination of these things for years. It's actually how I landed job offers earlier in my career. My gripe with these methods of studying is one, the time commitment required to feel comfortable in a specific algorithm topic is super high, and two, it's incredibly difficult to truly understand a topic as a whole when you're studying in this way. The core issue is that these approaches encourage memorization of individual problems and not entire algorithm categories. So what's a better strategy? Algorithm pattern recognition. The idea of this strategy is to focus on one algorithm category at a time, such as backtracking or binary search. Once you identify the category you want to focus on, attempt to solve 5 to 10 of the most common problems for that topic. If you have to look up the solution, no problem. Just at least attempt 5 to 10 problems. Now, for all of those problems that you attempted or solved, open all of the solutions side by side. I want you to look for similarities in the solutions. Are there a common set of variables? Do the conditionals between the problems look similar or potentially identical? Do the solutions share a common set of data structures? Maybe all of them are utilizing a set or a Boolean array. As you're identifying all of the similarities between the solutions, you will be implicitly deriving a pattern for that category. This could also be referred to as a mental model. The next step is to actually write this pattern down, either on paper or in your favorite code editor. If you feel like you couldn't find many similarities between the solutions, no problem. Go and solve more problems for that topic, or potentially look at other solutions outside of your own. From my experience, all algorithm topics have a pattern. It's just about deriving it. I also want to mention that this strategy is not always perfect. Of course, there will always be outlier problems that don't necessarily conform to the pattern that you derive, but it's more important to focus on solving the majority of problems rather than focusing on the minority. The last time I was looking for a job was in 2021, and I credit this interview strategy for getting me job offers from Google, Salesforce, Atlassian, and Coinbase. So what makes this way of preparing for technical interviews so effective? To lay it out plainly, it is significantly easier to recognize a dozen or so patterns rather than attempt to memorize hundreds of individual algorithm problems. Pattern recognition comes naturally to us, and this is prevalent in all fields, not just programming. Musicians are able to recognize chord progressions through auditory pattern recognition. A doctor can diagnose and treat a patient by identifying recurring patterns of symptoms and blood work. Any field, you name it, a person is an expert at that thing because they spent potentially years being able to recognize a series of patterns. Well, guess what? We can do the same, and I'm going to walk you through an entire example. Top K element is a popular category of coding interview problems where you have to find a specific element or list of elements in a data set. Let's see if we can identify the pattern for this category. Here are 4 of the most common top K element problems on LeetCode. Kth largest element in an array, kth largest element in a stream, k closest points to origin, and top K frequent elements. One of these problems is marked as easy, and all of the other ones are marked as medium. One solution for solving kth largest element in an array is using a priority queue. We create the queue, loop over all the elements, add each element in the queue. If the queue size is greater than k, we remove the head, and when we're done looping over all the elements, the head element is our kth largest element. Now, what if we wanted to find the kth smallest element in an array? All we do is reverse the order in which we add elements into the priority queue. Let's go to the next problem. We're just trying to continue to build a mental model. This is the solution to kth largest element in a stream using a priority queue. Comparing this to the other two solutions, we can see that we are performing the same exact logic, adding each element from the stream to our data structure and returning the head element. If we want the kth smallest element in the stream, what do? Reverse the order for adding elements. Next problem, k closest points to the origin. Here's the solution. We create our queue, and since we're finding the smallest points, we reverse the order. Are you starting to see a bit of a pattern here? We then loop over our points, add each point to the queue, and poll if our size exceeds k. For this problem, we're looking for k values, not just the kth value, so we return all elements in the queue as our answer. What if we wanted to find the k furthest points from the origin? Easy, just reverse the order for adding elements. All right, final problem, top k frequent elements. For this problem, we need to get a count of each element. Once we have those counts, well, you look at that. This is starting to look like all of the other solutions we already looked at. We create the queue, loop over our data structure, add the elements to the queue, pull from the queue, and since we're finding k values and not just a kth value, we return all the elements in the queue. Using just these 4 problems, a pattern can easily be derived for solving top k element problems using a priority queue. We always create a queue, and if we are finding a largest value, we add the elements in ascending order. If we're finding a smallest value, we add the elements in descending order. We always loop over the elements, add the element in the queue, and poll if our queue size is greater than k. If we're finding k values, we return all the elements in the queue, and if we're finding a singular k value, we return the element at the head of the queue. And that's it. We now have a pattern that can always be referenced for these types of problems. Once you have the pattern, you essentially never need to study these types of problems again. This is one of the key beneficial reasons for studying in this way. Once you derive a bunch of patterns for different categories of problems, you will easily be able to refresh your memory on these topics many months later. You won't be starting from scratch. I've personally come up with over a dozen patterns across several algorithm categories, 7 of which I teach on my website, AlgosWithMichael.com. And when I'm wanting to prepare for an interview, all I do is look over the patterns that I derived. That's it. I don't have to solve hundreds of LeetCode problems in order to feel interview ready. I know this strategy will be effective for you because it worked for me time and time again, so I really encourage you to go try this out yourself. If you feel like this information helped you, I only ask that you like the video and subscribe to the channel. I've been at this YouTube thing for a really long time now, and I want to grow more. Also, if you sign up for the newsletter on AlgosWithMichael.com, you can gain access to some free algorithm tutorials relating to sliding window problems. So definitely check that out if you're interested. That is all I have for you today. Hope you have a great day, and I'll catch you next time.